Into this question is given that segment AB, BC and CD. So let's say these are the segment. Let's say this is AB, then BC, then CD. These are the three segments AB, BC and CD of a horizontal line which are subtending equal angles at a point O vertically above A. So the point vertically above A will be lying somewhere on this line, right? Let's say here is the point O, right? Now from here, if you see, it's mentioned that the all these three segments, that means AB, BC and CD, all these are of a part of a horizontal line and subtend equal angles at O. That means this AB is subtending some angle at O, and that angle is represented over here as what? It's theta. Let's say it's theta, because this is the same angle which is subtended at O by segment BC, and the same theta angle is subtended by the segment CD at O, right? So this line segments BC is also subtending an angle of what? Theta at O. And similarly, this line segment CD, this one, this is the line segment CD, and earlier this was AB. So this was AB, this was BC, and this was CD, right? And here it's mentioned that CD is also subtending an angle, equal angle at O. That means the angle subtended by CD at O, this angle is also same, and the value of that is theta, right? Now it's mentioned that if the length of OA, that means this length is given to you as A, the length of OA is A, right? And that of AB is B, this length is B, this length is B, A to B, the length of A to B is equal to a small b, right? Then we need to prove that, what we need to prove? To prove we need to prove that the length of CD is equal to B times BA square plus A square whole square divided by A square minus 3BA square, and into the denominator another bracket, and that is A square minus B square. So this is our requirement. We need to prove the length of this CD, this section CD, right? The length of this section CD from here to here is equal to B times B square plus A square whole square divided by A square minus 3B square multiplied with A square minus B square, right? Now To solve this question, we have already assumed the first part because both the three sections AB, BC and CD are subtending equal angles at theta at the center. So that's why from the triangle 1, triangle 2 and triangle 3, right? If triangle 1 is triangle OAB, all this is a right angle triangle. Okay, so this angle is 90 degree. Don't forget it. It's 90 degree. So if you consider triangle OAB, then we can write tan theta. Tan theta is equal to a small b by a, right? Can we write it? Tan theta is equal to b by a, right? We have taken the first triangle, this one, triangle OAB. So if here is the theta, AB is the perpendicular and OA is the base. So tan theta is perpendicular by base, which is basically AB by OA. Tan theta is basically AB by OA. And the length of AB is a small b and length of OA is a small a, right? So tan theta is equal to b by a, right? From this triangle we can see the first triangle, this one. Now similarly, if you consider triangle OAC, this one, triangle OAC, whatever is visible to you, then can we write it that tan of theta plus theta will be 2 theta, then tan of theta plus theta, which is equal to tan 2 theta, and the value of this tan 2 theta is equal to how much? Tell me. If this is 2 theta, tan 2 theta is equal to AC by OA, is equal to AC by OA. And what is the length of AC? Length of AC is this small b, right, plus BC, that is AC is AB plus BC. So let's say the length of BC as x. Let's say the length of BC as x. Let us assume the length of CD as y, right? So we have assumed two variables, x and y. The length of BC is x and CD is y, right? Then from here we can write tan 2 theta equal to AC by OA, and AC is basically b plus x. B plus x by OA, that is small a. So I am writing it over here, b plus x divided by OA, and length of OA is small a, right? So tan theta, tan of 2 theta, not theta, tan of 2 theta is b plus x divided by a, right? Now just consider the bigger triangle, triangle OAD, right? Should I mention the triangle name also? So let me mention. In triangle OAB, the first part tan theta, we get tan theta from triangle OAB, and we get the value of tan theta as b plus x by a by considering which triangle? Triangle OAC, right? So this we have considered. Now consider the third triangle. Which triangle? The bigger triangle, triangle OAD, that is from triangle OAD, right? From triangle OAD, what is the value of tan? This will be theta plus theta plus theta. So this will give you tan 3 theta, right? So this will be giving you tan of 3 theta, because this 3 theta consists of Which one? These 3 theta consist of theta plus theta plus theta, and all these 3 thetas are this one, and this one, right? This one, and this one, right? 3 thetas. And tan of 3 theta is equal to how much? It's AD by OA. AD by OA. And what is the value of AD? AD is B plus X plus Y, because AD is AB plus BC plus CD, and the value of AB is a small b, BC is a small x, CD is a small y. These are the two variables and one value is known to us. So that's why the value in place of AD we can write B plus X plus Y, right? Divided by OA. And what is the value of OA? It's same, A, right? So in this way, the value of tan 3 theta is also calculated, that is B plus X plus Y divided by small a, right? Now, we know that from the formula, tan of 3 theta is equal to 3 times tan theta minus tan cube theta by 1 minus 3 tan square theta, isn't it? This is a formula which I am taking. That is tan 3 theta equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta, right? Now, in place of all this tan theta, put up the values. We know the value of tan theta is equal to B by A from here, right? So just put up this value. So in place of tan theta, we put the value B by A, right? It's B by A minus, I'm just changing the pen so that it can be easily visible, and minus tan cube theta. So it will be B by A whole cube, isn't it? Because tan theta, value of tan theta is, you can see, B by A. Now, this one divided by 1 minus 3 tan square theta. So 1 minus 3 times B by A whole square, right? And when you solve it, you will get A cube will be the LCM into the numerator, A cube, and let me change the color of B by A over here into the denominator also. Now, when A cube will be the LCM into the numerator, it will be 3 times A square B minus, and here it's B cube, right? And this whole divided by what? We have 1 minus 3 B square by A square. So here also taking the LCM, the first term of the denominator will be A square, because this A square will be multiplied with this one. A square minus 3 times B square and whole divided by A square. So we can write it like this, right? So this will give this A cube and A square. From this A square, this A cube will be cancelled and only A will be left into the denominator of numerator here. right? And finally, when one b is taken common from this one, we get b by a, right? This a and this b taken as common, and inside the bracket we have 3a square minus b square. 3a square minus b square divided by, into the denominator we have, tell me, a square minus 3b square, right? So this is the value of tan 3 theta which we have calculated. Tan 3 theta is this much, right? Now here tan 3 theta is calculated. Now we have almost solved this question. Let us see how. But this tan 3 theta is equal to b plus x plus y by a, isn't it? So just equate it with b plus x plus y by a, right? And from here we can see the value of y can be calculated in form of x. How? Simply, it's b by a, right? So here you can see this a is cancelled out, right? This a is cancelled out and we are left with b times 3a square minus b square by a square minus 3b square, right? And from here we subtract b and x, so we get the value of y as, get the value of y from here as equal to b times 3a square minus b square divided by a square minus 3b square, right? So this is the value of y, mind it. So the value of y is calculated as this much minus b minus x, right? So this minus b minus x, so that is minus b plus x. Minus is taken as common, right? So this is the value of y which is calculated. Why I am taking these values? Because it will be used directly over here into the next steps, right? So this is the value of y which is calculated. Also, let us put up the value of this tan 2 theta equal to b plus x by a and see what is coming. Okay, so I'm writing over here, since tan of 2 theta is equal to b plus x by a, isn't it? Here you can see this. I'm directly writing it again over same here. Writing the same statement over here. Tan 2 theta, the value of tan 2 theta is equal to b plus x by a, which I have taken. Now, what we will do, since tan 2 theta equal to b plus x by a, then from here we substitute, we just put up the value of b plus x. How? Can't we write a into tan 2 theta is equal to b plus x? Simply multiplying the denominator of RHS into the LHS numerator. So this will give you a multiplied with this tan 2 theta and this is equal to b plus x, right? Now the tan 2 theta, the value of tan 2 theta, just put it, tan 2 theta is tan 2 times tan theta divided by 1 minus tan square theta, isn't it? And this is equal to, tell me, this is equal to the value of b plus x, definitely. So here you can see that tan theta is coming. Now what we will do, we'll put up the value of tan theta as b by a from here. So into the RHS, b plus x will be coming as usual, right? So just put up the value of tan theta as b by a over here. So this will be a into 2 times, in place of tan theta, I am just changing the pen to show you. In place of tan theta, write b by a. 2 times b by a divided by 1 minus tan square theta. So this will be equal to 1 minus b by a whole square, right? This will be the value of b plus x only. So this is coming as usual into the RHS, right? So this will give you, here you can see, this a and this a will be cancelled, right? This a and this a will be cancelled, and this a square, when taking into LCM, the denominator of the denominator over here will be a square minus b, right? A square minus b square, because this square is for b and a both. So a square minus b square, and this the denominator's denominator, that is a square, will be going into the LHS, going into the numerator, and it will be giving you 2b, and this a square, this will be giving you 2a square b. So you are getting the value of b plus x. The value of b plus x is calculated, and that is equal to 2 times a square b by a square minus b square is equal to, that is the value of b plus x, right? Now we will be using these two values, the value of b plus x and y. How? Because here you can see b plus x is there. So in place of this b plus x, we will put up this value. Then we get the value of y is equal to, let me write it over here. Then we will get just, so writing here, since y is equal to b times 3a square minus b square divided by a square minus 3b square, right? The first term minus b plus x. So b plus x, in place of b plus x, put 2a square b by a square minus b square, this one, the value of b plus x. So minus 2a square b divided by a square minus b square, right? So here you can see a square minus 3b square, right, into the denominator, and a square minus b square. This was the same which we are about to prove. CD, the length of CD is nothing but what? It's y. It's y only. And in this way we have almost proved it. Y is equal to a square minus 3b square by b a square minus b square into the denominator, and which is matching over here, right? Let us see what we can do with the rest of the numerators, right? So let us solve it. And taking the LCM, b times 3a square minus b square will be multiplied with this a square minus b square, right? Minus 2a square b into this a square minus 3b square, right? And into the denominator these two terms, that is a square minus 3b square and this one a square minus b square. I just try to put the colors into different so that it will be easily understandable, right? So this will be giving you, here you can see, when you just multiply it, you get 3a square into a square will be giving you 3a power 4, right? 3a power 4, 3a power 4, and anywhere else we are getting a power 4, here, 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 nobody, nowhere else. Now simply do it, just expand it, right? So b into 3a square into a4, so this will be give you 3b into a power 4, a square and a square, again minus 3 a square b cube, how this a square multiplied with this b square and again this b. Don't forget to consider this b because this is also multiplied with each of the two terms. So 2 and 2 will be giving you 4 terms over here, right? Then the term of b square will come, then minus b cube into a square. So we can write minus a square b cube, right? Minus a square b cube. Then the fourth term minus plus b power 4 and this b, that is b power 5 is coming, right? B square and b power 4 and this b, that is b power 5 is coming, right? So these two terms are expanded. Now the last two terms here will be minus 2 times a4b, a power 4 into b, a power 4 into b, then plus minus plus 3 to power 6, 3 into 2 6, 6 into a square b cube, a square b cube, right? So here you can see a4b and a4b are there. So I'm not writing here the denominator, this is only the numerator of y, right? So this will be further simplified. We are not disturbing the denominator because the denominator is matching with the requirement what we need to prove. So into the numerator we have 3b a power 4 minus 2b a power 4. So this will be giving you b into a power 4, right? B into a power 4 minus 3a square b cube and plus 6a square b cube. Here you can see 6a square b cube minus 3a square b cube and again minus a square b cube. So here is minus 4a square b cube plus 6a square b cube. This will be giving you plus 2a square b cube, right? After that, we are left with only one term, that is b power 5 plus b power 5. So this is numerator only, mind it, because denominator is already matched. Here you can see this one. This is the denominator which is matched with the requirement. So we are just working on the numerator only. So here you can see if b is taken common into our requirement, then we are then if b is taken as common, then we have b times a square. We can write it a square whole square instead of a4 plus this b5. When b is taken common, b4 is left, so we can write b square whole square, and here b is taken common, so 2a square b square. So this is into the form of x plus y whole square, that is x square plus y square plus 2xy. So we can write 2 times a square into b square, because b is taken common from here, here and here. So this numerator will be looking like this, and this will give you b times b square plus a square whole square, because this is into the formula x square plus y square plus 2xy. So this is the same numerator which was required, right? So this divided by your denominator. What was your denominator? That is a square minus 3b square multiplied with a square minus b square. And we have proved the length of CD, that is y, is equal to the same which was our requirement. And in this way such questions can be solved. Thank you, students. So if you find it useful, you can just like and subscribe. Thank you so much for watching. Take care. Bye bye.